In my 14 years of journey as an IIT JEE Maths faculty, I have seen students facing a lot of problems, especially in questions of summations in binomial theorem. So in this video, I am going to simplify your life by giving you 5 different kinds of questions and 5 different types of tricks how to solve those 5 different types of questions based on series in binomial theorem. So without any further delay, let us start with it. Now in this next problem type, that is type 4, we have binomial coefficient into binomial coefficient. In this question, first we need to understand what is the core concept behind it. So if I am writing 1 plus x raised to the power 2, the expansion would be 2c0 plus 2c1 into x plus 2c2 x square. This will become 2c0 x square, 2c1 x and then 2c2. And now we are going to multiply them. If I multiply, my left hand side becomes 1 plus x raised to the power 4. And right hand side, if I want to get the constant term, I will have to take this term and multiply with this term. Only then the constant term will get generated. For constant term, it would be 2c0 into 2c2. If I want to get the coefficient of x, in that scenario, I will have to take this 2c0 and multiply with 2c1 term. This would be one combination, and then 2c1 term and multiply it with 2c0. So as a result, what are we getting? This will become 2c0 into 2. If I want to get the next term, I will have to take 2c1, that would be this term, and multiply it with 2c2. This becomes 2c1 into 2c2. Then if I want to get the term of x square, I will move ahead and I will multiply this term with 2c0. That will mean 2c0 whole square. Then 2c1 with 2c1. So 2c1 into 2c1. And then 2c2 into 2c2. This will become 2c2 whole square. Now even we can write this as 2c1 whole square. And then so like this we'll keep on doing, and we'll get further a term of x cube and further a term of x raised to the power 4 as well. So you can see that what you have done is you have multiplied two series, and as a result you got terms involving constant, then x and x square, then x cube, then x raised to the power 4. And it is justifiable because you are multiplying a quadratic equation to a quadratic equation. The highest term is going to be 4, the minimum term is going to be 0. Now what is the logic behind this is, now if I write the same terms on the left hand side, the expansion on the left hand side would be slightly different. So this expansion is going to look like 4c0 plus 4c1x plus 4c2x square, 4c3x cube and 4c4x raised to the power 4. So what we are saying is, see, since both of these series are equal, the corresponding coefficients of x should also be equal. That would mean if I compare both of them, my 4c0 should be equal to 2c0 into 2c2. First result. My 4c1 should be equal to 2c0 into 2c1 plus 2c1 into 2c2. And similarly, my x square term, that is 4c2, should be equal to 2c0 whole square, 2c1 whole square and 2c2 whole square. So this is happening. And we can keep on doing. In fact, we can write 5 such results. So you can see that this is the idea behind multiplication of two binomial expansions. What you are getting on the right hand side is multiplication of two binomial coefficients. So most of the times you will not have to do it in this order. Most of the times you will be given a series that involves multiplication of two binomial coefficients, and correspondingly you will have to write the sum. Now let us see how to attempt a question and what are the standard results into it. But first, I hope you were able to understand what we are fundamentally doing. Now let us say that this is an important result in front of us. So what we are doing is, here a very important thing to notice is, if you look into the difference of the subscript that is written, it is same. In all the cases, it is equal to r. So here, difference of subscript is same. This is very important to understand. Why? Because now understand there is going to be a simple process. First, we are going to write the expansion of 1 plus x raised to the power nc naught nc1x, and this is the same thing that we did earlier as well, nc2x square, nc3x raised to the power 3, so on and so forth. We'll go till ncn x raised to the power. Now, since the difference is same, we are going to, in the same second step, replace x by y and y by x, and to replace or change the order. Now, this is going to become nc naught x raised to the power n, then nc1 x raised to the power n minus 1, and if I keep on writing, I will get a term nc, here this is going to become x raised to the power n minus r, then nc r plus 1 x raised to the power n minus r plus 1, and this will keep on going like this. If you write these two series, the one in the ascending order of the x, one in the descending order of the x, the third step would be to multiply them. If you multiply them, what is going to happen? On the left hand side, we have got 1 plus x raised to the power 2n. It is same as what we did earlier when the power was 2. There is no difference. But now we understand that there would be different coefficients. We don't want every coefficient. We want just one that is corresponding to the series that is given to me. मतलब क्या है? When you are taking this nc naught, it should get multiplied to ncr because this is what my first term is. ठीक है? Now, if you closely observe, if this gets multiplied, what is the coefficient of x getting generated? You can very easily see that the coefficient of x that would be generated is x raised to the power n minus. Second, I can keep on doing so. nc1 is there and then it is getting multiplied to ncr plus 1. Again, if you multiply, the coefficient is going to be x into x raised to the power n minus r minus 1. It becomes the same thing, x raised to the power n minus r. So what we have observed is, if I see this particular term, so there would be terms before it, there would be terms after it. But if I look into this particular term that is getting generated, if I multiply nc naught with ncr, nc1 with nc r plus 1, the coefficient of that is x raised to the power n minus r. This is very crucial thing to observe. Why? Because the coefficient of x raised to the power n minus r is going to be same. Now we are going to compare coefficients on both sides. Coefficient of x raised to the power n minus r in 1 plus x raised to the power 2n. This is going to be 2n c n minus r. You can see that this becomes the answer to this question. So the answer to a series that looks like this, nc naught, ncr, nc1, ncr plus 1, can directly be written like this. So there are 4 steps involved. In the first one, we wrote the series in ascending order of x, second descending order of x, then multiplied them, understood the series that is given to me is corresponding to which power of x, compared the same power of x from the left hand side and got my answer. This is a very standard process. Now what we are going to do is, one, this becomes a standard result. What can change is the power of 1 plus x, that could be m and something else also. And corresponding to that, the superscript of NCR will also change. Okay, this is one change that can happen. Second change that can happen is, instead of R, there could be something else also. So these are the 2 changes that you will see in most of the questions. So now once you have understood what is the standard result for this part, so this result can either be written like this, or if I apply NCR is equal to NCN minus R, this can also be written as 2NC n plus R. Either you write it like this or like this, both the things are same. So you have looked into the idea where the difference of subscript is same. Now let us take an idea where the sum of the subscript is same. So what I am writing is NC naught into NCR, then NC1 into NCR minus 1, then NC2, NCR minus 2, so on and so forth. Now in this case, what is happening is the sum of subscript is constant. This is what we are trying to do. So if you take the sum here, this comes out to be R, sum is again R, sum is again R. So sum is same. Earlier the difference was same. So what would be the change in the solving process? We are going to write the first step as same, expansion of 1 plus x raised to the power n, nc naught, nc1x, nc2x square, nc3x cube. And then in the second part, instead of changing the order of 1 and x, we will keep the order same now. So NC naught, NC1x. And if I keep writing terms, there would be a term of NCR, x raised to the power. Before that, NCR minus 1, x raised to the power r minus 1. Before that, there would be NC r minus 2, x raised to the power r minus 2. And this will keep on happening. Now, what we are doing is we are going to multiply them. If I multiply, the left hand side would be 1 plus x raised to the power 2n only. There would be multiple terms, but we want a term in which NC naught is getting multiplied to NCR. You can see that if this multiplication happens, the coefficient of x will become r. So let us write this down. So this becomes x raised to the power r. Then next one, I am multiplying NC1 with NCR minus 1. Still the coefficient of x is going to remain same, x raised to the power r only. If I write it down, this is NC naught into NCR, NC1 into NCR minus 1 will keep on doing the same. What we want, what we have understood is, now we will do comparison. We will compare coefficient. What we want is the coefficient of x raised to the power r in 1 plus x raised to the power 2n. And this is going to be 2NCR. And we know that this would be equal to NC naught into NCR, NC1 into NCR minus 1, NC2 into NCR minus 2, so on and so on. So you can see that this is a standard result that we can write. So we can write it like this also, and if we apply NCN minus R, it can be written like this also. It does not matter. This is easy to remember. So two special cases. One is what happens when the difference is constant. Second, what happens when the sum is constant. Now, once you have understood this, let us move towards a very important result that can be derived directly also and indirectly also. So, if I want to do directly now, you can see that NC naught square fundamentally means you have NC naught into NC naught. You have NC1 into NC1, NC2 into NC2, like this it is happening. This is the series that we want to sum for. You can see that the difference of the subscript that is constant, that is always 0. So there is a long method, there is a short method. First I will tell you the short method, then we'll do the long method. See, now we already know a result. Instead of solving and doing the whole 4 steps, we can directly apply the result that we learned earlier. So our result was NC naught into NCR, NC1 into NCR plus 1. If I do this, the answer was 2NC n minus r. This is what we got. So now, if you compare this in the series that is given to me, what you can see is, see, this part, that is the first part, is same. What is different, that you can notice, is the second part. What can I do so that this also becomes same? So for that, you can see that in the second result, if I just put the value of r as 0, then my result is going to become NC naught into NC naught, NC1 into NC1, so on and so forth. And the right hand side will become N minus 0. You can see that you have got the sum of the series NC naught whole square, NC1 whole square. This is going to be 2NCN. So this is a shortcut. So whatever we did earlier has now become a result, and we are using that result to get the answer. Now, if you don't feel comfortable in doing this, you can still do your 4 steps. Your 4 steps are still valid. There is no problem and no shame in doing that, because that is a more fundamental way of doing things. So now, if I write my general term, now what is going to happen is, I am going to write my series 1 plus x raised to the power n. This can be written as 1 NC naught plus NC1x, NC2x square, so on and so forth. Again, in the second step, I will write x plus 1 raised to the power n, because the difference is same. So NC naught x raised to the power n, NC1 x raised to the power n minus 1, NC2 x raised to the power n minus 2. Third, we are going to multiply them. If I multiply, it is going to become 1 plus x raised to the power 2n on the left hand side. And since now we are multiplying this term with this term, as a result there would be multiple terms, but this will generate NC naught whole square. Then we will multiply NC1 with NC1. This will generate NC1 whole square, and you can see that all of this term, the coefficient of x is coming out to be n. So what we want is not all the terms, but the coefficient of x raised to the power n on both the sides. So in the fourth step, if I compare, you can see that what I want is x raised to the power ka coefficient in 1 plus x raised to the power 2n, and that is 2ncn. And that becomes the sum of my series nc0 whole square plus nc1 whole square till ncn whole square. So you can apply your 4-step standard process, and that is more general process, can help you solve more questions. If you want to solve faster, you can apply a result as well. Now let us go to another question. Here you can see that again we have been given a series, but instead of doing 4-step process that I believe now we will be able to do, let us apply the result. So let me write my standard result, becomes nc0, ncr, nc1, ncr plus 1, because the difference is same. So 2, 2, 2, that is happening. So that is the reason this result is getting used. So the answer is 2ncn minus r. If I compare them, you can see that the first term is same. So this is same, this is same. So what if this could become same, my answer will come. So now you can very clearly observe that if the value of r becomes 2, this will become same. If I put r as 2, here also r will become 2, and my answer will become 2cn minus 2. So this becomes a 1-step question if you directly apply the result. Now what happens in this case, where in the first binomial coefficient there is m, in the second one there is n. What will you do now? So again the same 4 steps are good enough to solve any question. We will write 1 plus x raised to the power n. It becomes nc0, nc1x, nc2x square till ncn x raised to the power n. What is happening is you can see that the sum is constant. So when the sum is constant, you do not change the value of 1 and x. But since there is an m in the superscript, we will also write m in the superscript. So 1 plus x raised to the power m, mc0, mc1x, and then there would be a term ultimately mcr, x raised to the power. Before that there would be mcr minus 1, x raised to the power r minus 1. Before that mcr minus 2, x raised to the power r minus 2. Now if you multiply them in the third part, what I am going to get is 1 plus x raised to the power m plus n. And this term will come when what I am doing is I am multiplying nc0 by the first term, nc0 by mcr. If this multiplication happens, so this will become nc0 into mcr. You can see that the coefficient of x is coming out to be r. Let us do this one more time just to confirm things up. nc1, if this gets multiplied to mcr minus 1, because that is what my next term is. Now you can again see that if this x gets multiplied to this again becomes x raised to the power r. So let me write the next one. So you can clearly see that what we want here is in the fourth term, in the expansion, what we want is coefficient of x raised to the power n, r in 1 plus x raised to the power m plus n. This will become m plus n cr, and as a result, this becomes the answer to the expansion mcr, mcr minus 1 nc1, mcr minus 2 nc2. Not very difficult. You can see that you can do small variations here and there. Largely things will not change. One last question, and you can see that here things are changing a little bit. What we are getting is a coefficient into binomial coefficient into binomial coefficient. So what I am saying is if you write a general term, here it looks like this, r into ncr into ncr. This is the pattern that is happening in this question. And you have combined the earlier two problem types. It could also be binomial coefficient into binomial coefficient divided by constant. But the process of solving both these questions will remain same. What we are going to do in the first step, let us first write the general term, because general term based method, I am writing general term, that is r ncr ncr. And now in the second part we are going to apply property. So if I apply property, this can be written as n by r So you can see that we are solving as a question based on R into NCR. So the same method we are adapting here. And in the third part, we are going to rewrite the series. So now you might be thinking, sir, this is exactly same question as what we did earlier. Yes, it is the same question that we did earlier. So if I start putting the value, it was the value of R starts from 1. So this becomes 0 into NC1 plus N minus 1 C1 NC2. Now we need to find the sum of this series. Now this is a question that we just solved. This is a question that we just solved. Then the next step, that is my fourth step, in which we need to apply result. In place of result, this step will change. In order to get it, we will again do our 4 steps. We will write 1 plus x raised to the power n minus 1. This would be n minus 1 c0, n minus 1 c1 into x, n minus 1 c2 into x square, so on and so forth. Now we can see that here the difference is same. We will change the order of 1 and x, and since the superscript is n, we will write here n. So this will become nc naught x raised to the power n, nc1 x raised to the power n minus 1, nc2 x raised to the power 2, n minus 2. And then we are going to multiply it. So if I multiply, in the left hand side we get x raised to the power n in plus n minus 1. On the right hand side, what we want is basically nc naught in c0. So nc naught c0 is this term, should get multiplied with nc1, this term. And as a result, if this multiplies, what is the coefficient of x that we are getting? It is x raised to the power n minus 1. And then, so let us write it, n minus 1 c naught into nc1. Then the next part will happen when I take n minus 1 c1 and it gets multiplied with nc2. Here also, when you are multiplying, what is the coefficient of x that will get generated? It would be multiplication of these two. This is the same term. You should at least confirm it once before moving ahead. So now you can easily observe that if I want to get the answer that is given to me, a series that is given to me, that would be coefficient of x raised to the power n minus 1 in 1 plus x raised to the power 2n minus 1. So answer of this comes out to be 2n minus 1 cn. So the sum of the series that was asked to me becomes n into, put this value, 2n minus 1 cn. You have got your answer. You can see that the first 3 steps remain same. Just in the last step, we are using what we just learned. Now let us do one more such question so that it gives you more sense of clarity. So again, we'll start with general term. Now the general term in this case will become 2r plus 1 NCR whole square. So now you can see that here I can have one more shortcut into place. The earlier thing I can do, but I can do a shortcut also. So if I apply properties, I can write this as 2 into r into NCR whole square plus NCR whole square. So what is the property? See, if you are applying summation over it, r NCR whole square, so you will get your series. The value of r that you are starting with is 0. You will go till n. Here also we are starting with 0, will go till. So now this is the series that we just solved. ये तो ऊपर किया था देखो. This is the series that we just solved. The answer was n into 2n minus 1 cn minus 1. So you can directly substitute this value. And the answer of this question was a result. This is 2n cn. You can see that from what we did earlier, we were directly able to pick up a result and get the answer. I think there is an n missing here. Let us say. Let me check for the earlier question. Yeah, fact. You can see that we can combine earlier questions and do certain questions even more faster. 60 days to JEE Mains. Let me tell you something that nobody else will. The brutal truth. Right now, you have doubts from class 11th you never cleared. Topics you are avoiding, formulas that you kind of remember. And you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PracBee, we have produced 10 times better result than national average and help More than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt. They had a strategy into place. And that's what Last Lap Booster program does. Senior ITN faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.